Hey everybody, this is Larry. This is the third day of the June Leetcode Daily Challenge. Let's get right to it. Hit the like button, hit the subscribe button. Let me know what you think. Two city scheduling. There are two N people a company is planning to interview. The cost of flying I person to city A is cost of I to 0, and the cost of flying I person to city B is cost of I sub 1. Return the minimum cost to fly every person to a city such that exactly N people arrive at each city. Okay. Hmm. So, so my first instinct, to be honest, is dynamic programming. This is what's that algorithm called? A sort of a knapsack. Basically, you know that N person has to be in A and N person has to be in B, and then you just kind of do, you know, the algorithm there. Is that, and I think, and my thought process right now is whether I can do better, right? And let's say I do want to do it with dynamic programming. In this case, there'll be N is equal to 100, or yeah, N is equal to 100. Each cost is less than 1,000. So in theory, A can be up to 50,000 or so for half of it, and B can also be up to 50,000. And we can do some implicit thing so that yeah, and so that's my initial thought process. And I'm just trying to think whether is there a greedy algorithm? Can I do something a little bit better? Because so greedy algorithms are always tricky with these things for me, particularly. For me, the easiest way was for me to reduce a problem to another non-greedy problem, and but here I don't remember that one. So I'm just thinking through it a little bit. But yeah, maybe let's just do that then. Maybe we. So the tricky thing on this problem as well, in terms of trying to figure it out, is also a naive way of doing the dynamic programming might be just have the states of N and then the total cost of A and then the total cost of B. But of course, in that case, as we mentioned, the total cost of A could be 100,000, and 100,000 squares is not going to be cut it. It's not going to be fast enough. So we have to do a little bit smarter. And maybe the answer is just keep track of A. And in this case, we have, because they have different costs, that would be a little bit, that might be a little bit tricky, or at least I don't know off the top of my head. I think one thing that we may be able to do greedy about is just, instead of dynamic programming, I think there's a greedy in which for each person, we greedily, so for each person, we calculate what's the cost of, so instead of having two numbers to calculate, there's the cost of city A and the cost of city B, which is kind of a messy concept. But what we can do is represent each number as kind of the absolute. We can keep track of what's the cost of putting this in A, right? And we could convert the entire array that way. And what I mean by that is, say that's given here. In a way, it's like renormalizing. That's how I would think about it. But instead of saying, oh, this is 10, but B is 20, what we can do is say, okay, the cost of this to put it in A would be 10. Oh, sorry, would be negative 10 to the entire system, because you have to put the person in A or B, right? And then the same similarity for the second, well, and here's cost is 350, this is 10, and so forth. So given that, I think we can now calculate the cost of putting n people in A as the total cost, and then we just have to. I mean, it's still a little bit hand wavy because it's still a little bit murky in my head. So I think from that we should be able to use the sum of everything to figure out essentially how much the total cost should be. Okay, so let's just say delta cost is equal to x minus y, or sorry, a cost minus b cost for a cost comma b cost in costs. So this is just an iterator, and let's just convert it to a list to be sure. And this is why you should put this in the bottom, because it messes with my indenting. And just to test, you could put delta. But this is basically for comprehension. It's very Python-y. But basically what it's saying is that for each A, B, and B cost and cost, which is each of these items, we just take the delta of them. And then now we figure out, and there might be a couple of things that I'm playing around with with respect to greedy, because greedies are always a little tricky. So then the next thing that I might think about is, does it make sense to be greedy about the minimal cost for A, or is it the minimal cost for B, but we do want the total cost, right? So in that sense, maybe what we actually want is not just the delta of A cost B. I mean, that's what this array tells us, but we want to start with the biggest difference that there is, right? So in this case, 350 is really expensive, so we definitely want to value B first. And for these greedy problems, to be honest, it's really hard for me to prove. Mathematically, it's a little bit tricky to prove correct without a reduction to an existing greedy problem that I know, or some property that I've just been playing around for a long time with experience. But I think for here, at least intuitively, it makes sense, even though you can say that about a lot of greedy problems and that gets you into trouble. So, but okay, so let's actually try again. I just want to illustrate that's how these are the thought process that you may think that I'm maybe wasting your time a little bit, and maybe you're right. And I apologize, but this is actually my thought process for greedy problems. This is me playing around a little bit with, okay, like how do I reconceptualize this problem in a way that allows me to look at it from different angles, right? And some of these angles are going to be a little bit not useful directly, but some of these angles will allow you to be like, okay, well, now that I visualize the delta cost like this, well, actually, does it make sense? I mean, like initially, maybe it makes sense to have negative 170 first, but 350, we probably, for that item, it really makes sense to be put in B first and other stuff, right? So, okay. So that's kind of my idea around constructing this greedy algorithm. But of course, there's the implementation part. And the implementation part, you would have to just practice a lot. But so sometimes my code might not come out as great the first time. But let's try again. So now let's just try again, because in costs. So now the cost is equal to just start a list. I should even look at this, but it's what we said it was, because so then maybe we do something like, I guess they could be equal, but it doesn't really matter. If they're equal, then it gets sorted in the back anyway, because you want to sort, or at least my idea would be to sort by the absolute value, and if they're equal, then it really doesn't matter at that point, right? So they'll be all the way in the back, because that's literally the lowest value you can go if you sort by the max of the whatchamacallit. Okay, if A cost is equal to greater than that, then we just append A cost negative. Well, so we do want to sort by minimum. So, but actually, let's keep the same thing that we did before, and then we'll just change the sorting function so that it matches more with what we. Because you want your code to match your idea as closely as possible. Sometimes you have hacks for competitive programming, but in real life, you definitely should write cleaner code. But let's just do A cost, B cost. and then just put it in. Oh, and then I was just going to say, let's just put a character. It doesn't really matter. But we also probably actually want to put in the A cost, B cost just for bookkeeping. So this part is not as necessary, but it's just for bookkeeping. I think it should be okay. And then else is the same thing really, but with B. So actually we could probably refactor this, and let's do, because let's just do best is equal to A. If this is the case, then that just had to be best is equal to A. And then now we can just do this, right? I think we might have to do some maths around. Oh no, I guess it doesn't really matter, because what I was thinking was that I might have to do some guarding so that we make sure that only n is in A and n is in B. But I think it doesn't really matter in the sense that at the end of your grid, you have to force to just put your things wherever it goes, right? So it doesn't really matter. Okay, and then now we can maybe start the grid as we implement it, as we say. So let's start with cost is 0, then we're going to sum up this cost. So let's just return the cost. But actually, I forgot a step. Well, I didn't forget it, but let's go back and make sure we did the step, and which is we want to sort this, and we want to, in Python, we could sort it by a key, and let's set the key is equal to, let's just say per on the element. We want to sort by the negative, the absolute value of the 0 element, right? And then actually that, and then the negative version of that, so that the larger negative numbers are in the front. You could also have done just regular absolute value and then reverse it. But yeah, I'm just going to do this as a shorthand. Make sure you, if you're in an interview, make sure you am able to articulate that. Cool. So then now let's just go through the delta cost, right? So now we actually don't even care about the delta cost anymore. So let's just put it in underscore. But A cost, B cost, let's just call it, I call it best. So let's just do side in delta cost. Let's just call this side. Don't be afraid to refactor your code, because sometimes it just helps with the readability, and then it's fine. Okay, so let's say this is the case. Let's also keep track of number of A's and number of B's. You could do it in a couple of number of ways, but I just wanted to make this a little bit. This is just the way I'm going to do it, I guess is my point. And you could do it, play around the implementation, do whatever you feel like and makes comfortable sense to you. Don't let and then start to build on that. Don't worry about like being perfect in the beginning, because you're not going to be. Okay, so now let's just say if side is equal to A and A is less than, do we have an N? I guess we're not giving an N. So let's just say N is equal to length of cost. So if NA times 2 is less than N, and what this is just basically saying, and if N is greater than NA times 2, I mean, that's obviously, but I meant N over 2 is greater than NA, kind of roughly. Basically, it's just saying that if half of the numbers are in NA, then we'll put it on A. Because if NA has too many numbers, that means we went overflow, so we have to put some on B, even if it costs more. So then now we just do cost. We're going to put this in A. Let's increment N A, and then else is cost is equal to B cost, and then N B. As you can see, we don't actually use this, but we'll just keep it in there for symmetry and possibly debugging. So let's run this real quick. There are no second test cases. Ooh, 650. That's not great. Oh, I think I got the sides wrong. Because if A cost is bigger than B cost, then we want to take the B side, right? That's kind of maybe obvious, but I just got the sides wrong. Because instead, we got the maximum answer, I think, probably, if the grid works. So now let's submit it. Well, are there any edge cases that I want to consider? Why is this? This cannot be 1 if cost.length is even, but I guess they were just a little bit lazy in the constraints. That's okay. We don't have to consider the other thing that I would also, something that I don't do enough on stream is to consider the overflow case. And what I mean by that is int overflowing 32-bit ints to 64-bit ints so that you have to do it in better calculation. The reason why I don't do it is because in Python you don't have to, but definitely in your language I would consider thinking about it. And in this case, the biggest return result would be 100 times 1,000. So it's 100,000, which is less than 2 billion or so. So that's way okay. So those are the things that I would think about in terms of test cases, but they don't apply here. So I'm just going to do another quick one. In this case, it should be, without looking at the answer first, what should it be, right? Well, it's either A is in 10 plus 200 or 30 plus 20, so it's probably 50. Okay, that looks okay. Let's submit it real quick. Oh, as quick as, ooh, wrong answer. And that's why greedy solutions are dangerous. But, okay. So now let's take a look at why this may be the case. I thought that would work, actually, to be honest. But okay. So the tricky thing sometimes that I would say is that you may get an answer that you don't know how to debug, because this is just like, you look at this and you're like, well, I mean, okay, at least we know what the expected answer is, but how do we match our current answer to the expected answer, right? And our algorithm and so forth. And it's kind of tricky. The way that I would say in general on how I think about it is try to come up with an obvious smaller case that is wrong, right? So yeah. So okay, so we put B first. So we put 118. We put this in A. No, let's just actually pick it up. But yeah, but it helps to visualize, at least go through the example a little bit, at least the case that you're wrong, just so that you can get a feel for things. In this case, we want 118 first, and then we do 259, which is fair. And then, okay. So this is the least delta. We put it in B. I think my question here is that, so there are a couple of things with greedy, right, and debugging. The first thing I would say about my my wrong answer is that it is better than the expected answer, and that means that there's something fundamentally just wrong about my algorithm in general, right? Because usually with greedy algorithms, when you're wrong, usually it's wrong in the other side, meaning that your answer is not good enough because your greedy was wrong. But because our answer is lower than the expected answer, that means that it's possibly the implementation is wrong and that the greedy algorithm is, well, it's not proven yet, but it's more likely that your implementation is wrong because, well, some invariant is not true. So yeah. And oh, okay. So I think I was really bad on one of the invariants, and that's my fault. I was trying to merge a couple of edge cases together, and I did that a little bit hastily. But I think but that allowed me the opportunity to explain how to debug this particular bad case for greedy. So I think that's worth it, maybe for you. Maybe if not, then you should fast forward. But what happened is that in this case, we do not check that nb is less than n, or half, that nb is not less than half of n. So in this case, in this example, you notice that here's a b, 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 b. So it was, in this case, it was still adding a b, or adding a number to b, and even probably in this case. So that's why we got a better, quote unquote, a better answer than we deserve. So let's change that. So else if side is equal to B, and I just do it the dumb way, because I think you could probably phrase this a little bit better, but I think now I'm just trying to figure out how to write this in a way that is clear without being a lot of redundancy. But let's actually get it right first, and then we'll think about the redundancy later. I think that's what I would say. So let's just do this, and then yeah, and then similarly, this will be true now. But yeah, sometimes that shows you that even if you're quote unquote good, I don't know if you consider me good, but good enough anyway, you still can't make these steps because you're a little bit too fast and you didn't really re-examine your answer, and or you re-examine your code because you're like, oh yeah, if this is not true, then it goes to the other one because it's forced, right? But then sometimes because of that, you don't think about the contrapositive case of, well, if this is not true, or if this is not true, does that automatically imply this? And the answer was no, right? And that was the edge case that I was missing. It's not really an edge case. It's a very basic case, actually. But I was just a little bit lazy in the typing, and yeah, and there you go. So let's submit it again. Hopefully this is good. So I should have retested the example cases, but I just forgot because I was a little bit watching it on the video. But that's okay. But you get my point. This is accept. Ooh, clicked on it by accident. But yeah. So that's pretty much how I solve this problem. So what is the algorithm? Well, the algorithm is going to be dominated by the sorting. So it's n log n. Space. Well, the way that we did it was by reconstructing a new array that we sort. But if you really wanted to, you can actually have rewritten this in a way that doesn't require extra space, because all these like I did this side thing just to kind of make an if statement easier, and even then I still messed up, so that's not the point. But and here you can just literally put it in the so you do not need the O of n extra space, but my algorithm or my implementation is O of n extra space, but you could do this in O of 1 space, O of n log n running time, and you could prove that both of those things are relatively good. Yeah, I mean, this is a very basic sorting problem. The greedy part, I always find it a little tricky, so I don't know how credible I am saying it. But for an interview, this is also reasonable difficulty. The tricky thing about an interview question on greedy that I always find on the other side is that it's just because someone is right, it's hard to tell whether they're right because they know the answer and understand the answer and be able to prove that it's greedy, versus they just guess and it was right? Where in other type of problems it's easier. But anyway, but that's just like more of a Larry thing, I think. And like I have I don't know. I think I would like to get more information as possible, but that's just me. So yeah, it's a pretty good problem, pretty interesting problem. I mean, I made a silly mistake, but it's a good thing that you practice and get those silly mistakes out of the way, so that next time you're like, oh yeah, I did this recently, so let me, if nothing else, you might not necessarily get it right perfectly really fast the next time, but the next time you do it, you'll be like, okay, wait, last time I did something similar, let me slow down, let me think through the edge cases, let me think through the if statements, let me think through the logical conclusion, so that I could be more sure that I'm right this time, right? And this is something that I do even now. For example, I know, like, knowing yourself and knowing your weaknesses, like I'm a little bit weak on sliding windows because of the off by ones on which pointer and so forth, right? So nowadays I would slow down and be like, okay, Larry, what is the left pointer? What is the right pointer? And that's how I think about it. But overall, and competitive programming, these things are like constructive E, greedy. They come up all the time, so you really have to just do it. And sometimes you just guess a greedy and it'll be right? Which is why it's a little bit, but that's how I feel about this problem. So yeah, that's all I have. Hope that was helpful, because I even though I did not solve this immediately per se, I hope that the debugging and stuff will, show a little insight about debugging in general. I think debugging is one of the most important skills as a software engineer in either case. And, getting it wrong, fine. But you're able to see my thought process and me able to debug the code in, less than a couple of minutes is, something that I'm proud of and happy with as well. Because in this case, in this problem, with a lot of other videos and a lot of other streams, you're probably just going to see, hey, this is how you solve this problem. But, and maybe even they do like, oh yeah, this problem is greedy because of X, Y, and Z. And you're like, yeah, okay. Like, how do you learn? I want to focus on how to show you my thought process in a way such that you're like, okay, now this is how to, like, not to say that you should think exactly the way that I think, but just like attacking the problem and having strategies to attack a problem and be like, okay, I'm wrong here. Why am I wrong? How can I fix this? How can I make things better, right? So that's how I would think about these problems. And I hope that this video helps in that regard. If you like it, hit the like button, hit the subscribe button, share with your friends, share with your family. And I will see y'all tomorrow. Bye-bye.